This is one of the most fascinating confrontations in modern astronomy, blending the scientific rigor of cosmic geology with the boldest frontiers of speculation about extraterrestrial life. At the center of this scientific whirlwind is 3I/Atlas, the third known interstellar object to pass through our solar system. Initially classified as just another traveling comet, the object gained explosive notoriety thanks to the bold suggestions of one of Harvard's most prominent astronomers, Avi Loeb. He not only proposed that 3I/Atlas could be an artificial probe sent by an alien civilization, but even suggested that its mission might actually be hostile. This theory, based on unorthodox interpretations of its orbit and composition, reignited the Pyrrhic fire about life beyond Earth, transforming a standard astronomical observation into a global headline. However, this narrative is being harshly challenged by a new, meticulous study from the renowned SETI Institute, which argues for an incredibly deeper thesis. 3I/Atlas is not a technology, but rather a geological fragment that may be, literally, older than the Sun itself, carrying with it the secrets of a planet forged in a primordial era of the Milky Way. The controversy reached its peak when Dr. Avi Loeb, renowned for his unconventional positions, including on the mysterious Oumuamua, publicly suggested the possibility that 3I/Atlas was of artificial origin. His arguments were based not on a clear image of bolts and rivets, but on supposed orbital anomalies and physical characteristics that seemed to defy the explanation of a comet or a common asteroid. For Loeb, the mere fact that the object followed a retrograde trajectory, moving in the opposite direction to most bodies in our system, and was nearly aligned with the ecliptic plane, the orbital plane of Earth and other planets, sounded less like an accident and more like intentionality, a sign that its trajectory had been controlled and carefully calculated for a specific visit. The scientific community, typically conservative in its claims about extraterrestrial life, reacted with cautious skepticism, but the media power surrounding the idea of an alien probe ensured that the interstellar object instantly became one of the hottest topics in astrophysics, boosting research and forcing a reevaluation of all observed characteristics. To strengthen his thesis, Loeb cited a crucial point: the absence of non-gravitational acceleration, NGA. In ordinary comets, the Sun's heat causes ice to sublimate, releasing gases that act as small propellant jets, creating what we call AGNG. The absence of this effect in 3I/Atlas suggested to Loeb that the object possessed an incredibly anomalous mass and was made of an extremely cohesive and dense material, impossible for it to be an icy and fragile comet. This abnormal mass led him to a surprising estimate, proposing that the body could weigh over 33 billion tons, a volume that would require structural support that seemed indicative of engineering. Adding to this hypothesis, he linked the supposed probe to the frightening dark forest theory, popular in science fiction, in which advanced civilizations remain silent or strike preemptively. According to this grim scenario, 3I/Atlas could be performing a reverse solar Oberth maneuver, a kind of covert braking near the Sun that would allow the object to establish itself stably and discreetly in our system, suggesting prolonged surveillance. In direct response to this wave of speculation and this extreme interpretation of the data, the SETI Institute, through researcher AKM Isenal Hack, has presented a solid and robust rebuttal. The new study posted on EarthAR14 proposes that 3I/Atlas is entirely compatible with known astrophysics mechanisms, challenging the need to invoke alien probes. The SETI team argues that the object, rather than being a hostile artifact, is a natural body whose trajectory and composition can be perfectly explained by celestial dynamics. This stance represents a return to scientific parsimony, the idea that the simplest and least speculative explanation should be the first to be explored. The central goal of SETI in this case is to redirect the debate from the search for advanced civilizations to understanding the deep and diverse geological history of the cosmos, using 3I/Atlas as an unprecedented opportunity to analyze materials formed in other star systems. SETI's main tactic for debunking the alien theory has focused on explaining the orbital anomalies within a broader natural context. The extremely high hyperbolic velocity, reaching 58 kilometers per second, and the retrograde motion are, according to Hack, simply the typical signatures of a body ejected by violent gravitational interactions from another star system, a chaotic and common event in the galactic environment. Crucially, the absence of AGNG, pointed out by Loeb as evidence of technology, is interpreted by SETI as proof of the object's robustness and density. Far from being an icy, porous comet that would release gases upon approaching the Sun, 3I/Atlas appears to be mostly rocky and metallic. Structural stability implies that it is a more cohesive and stable body, similar to an asteroid, rather than a pile of interstellar debris. Thus, the lack of acceleration is less a technological mystery and more an indicator of its intrinsically solid geological composition, disassociating it from the need for an artificial origin. Avi Loeb's argument about intentional orbital alignment, a trajectory nearly parallel to the ecliptic plane, was similarly dismantled by SETI using a cosmological perspective. Hack points out that the plane of the Earth's ecliptic is nearly parallel to the Milky Way's galactic disk, the region most dense in stars, and therefore the most likely source of ejected interstellar objects. It is statistically predictable that many stray bodies ejected from stars within the galactic disk coincidentally follow a trajectory close to the plane of our orbit, invalidating the idea of intelligent steering. Furthermore, subsequent spectral analyses provided compelling physical evidence that 3I/Atlas reflects light similarly to D-type asteroids, bodies rich in dark, volatile organic matter, common in the outer solar system, and the second interstellar object, 2I/Borisov. This spectral agreement strengthens the classification of 3I/Atlas as a natural object. In an eloquent summary, NASA scientist Tom Statler settled the come-tell aspect of the controversy by stating, "It looks like a comet, it does cometary things, and it is a comet," reaffirming the scientific community's commitment to its natural origin. However, the SETI study goes far beyond a simple refutation. It offers a twist more fascinating than the alien hypothesis itself. Hack proposes that 3I/Atlas is not just an ordinary rocky comet ejected from another star system, but rather a lithified clastic fragment, essentially an extremely hard sedimentary rock. This material, which suggests a process of geological compaction at high pressure and high temperature, implies that 3I/Atlas was not formed in a cloud of dust and ice, but rather ejected from the mantle or crust of a much older exoplanet. The key to this theory lies in the suggestion that the object may have originated in the Milky Way's thick disk, a region of the galaxy dominated by older stars, estimated to be around 7 billion years old. If this provenance is confirmed, it would mean that 3I/Atlas carries material formed before the birth of our own solar system, which is about 4.6 billion years old, making it a geological relic from a distant cosmic era. This new identity as a fragment of an ancient exoplanet has profound astrobiological implications, shifting the focus from alien technology to the search for the chemistry of life. If 3I/Atlas originated from an exoplanet that harbored liquid water in its remote past, it is possible that this rock fragment acts as a time capsule, containing fossilized chemical or mineral traces, so-called biosignatures of microbial life. This free sampling opportunity is invaluable, and the astronomical community has already drawn up ambitious plans to investigate it with the most advanced technology available. In October 2025, the HiRISE camera, attached to the Mars Reconnaissance Orbiter, will have the opportunity to capture ultra-high-resolution images of 3I/Atlas during its approach to Mars. Shortly thereafter, in March 2026, the Juno spacecraft will repeat the task as the object passes close to Jupiter. However, the secret weapon in exploring 3I/Atlas will be the James Webb Space Telescope, JWST. Researchers propose using JWST's precision infrared spectroscopy to delve deeper into its surface composition. The goal is to analyze the fragment for specific minerals that only form in the presence of liquid water, such as clays and carbonates. Detecting these substances would be the crucial link in validating the theory that 3I/Atlas is, in fact, a fragment of a watery world from another star. Rather than a sign of galactic war or a complex contraption, 3I/Atlas establishes itself in the history of science as an unparalleled testament to cosmic geological diversity. It offers the first and potentially the oldest physical sample of an exoplanet ever accessible to our observation, opening a portal to the composition and habitability of worlds formed in the galaxy's early days, long before Earth even existed.